Okay, so we're starting chapter 7 today, and chapter 7 is mostly about right triangles. And like I said, we're going to stop halfway through chapter 7 and do a test on right triangles, and then we're going to do trig separately, trigonometry, and have a quiz on trigonometry. So, section 7.1 is about applying the Pythagorean theorem. Raise your hand if you have heard of the Pythagorean theorem before. Raise your hand if you can say what the equation for the Pythagorean theorem is. What is it?
A squared plus B squared equals C squared.
Very good. A squared equals B squared plus C. A squared plus B squared equals C squared. It's written backwards a lot of times in geometry class. That's why I get confused, because we see it a lot in geometry. C squared equals A squared plus B squared. It's the same thing. Okay? So what that means in words is if you have a right triangle, the square of the length of the hypotenuse is equal to the square of the sum of the squares of the length of the legs. Woo! Lots of words. All right? So you say all that when you sum it up in A squared plus B squared equals C squared. C has to be the hypotenuse, and A and B are the legs. Well, what's the difference in a leg and a hypotenuse? How do you know what's legs and what's a hypotenuse? Yes, the legs make up the 90-degree angle. So in this figure right here, A and B are legs. C is the longest side of the triangle, and it's across from the 90-degree angle. It does not touch it. Okay, so it's opposite the 90-degree angle. So you have that theorem written on your handout, and we're going to use that to practice a few times finding a missing side or a missing hypotenuse. And this first example wants us to find the length of the hypotenuse. And we've got one leg has a measure of 8, and one leg has a measure of 6. We don't know the hypotenuse, so I'm going to give it a variable, and I'm just going to call it C, because C always needs to be your hypotenuse. All right, so we're going to plug it in the Pythagorean theorem, A squared plus B squared equals C squared to find C. So does it matter which leg you put in for A or B? It does not. Addition is commutative, so it doesn't matter which order you add two things. So just whichever way you want to do that, unless it tells you specifically to use one or the other. So 8 squared plus 6 squared equals C squared. What is 8 squared? 64. Plus what is 6 squared? Equals C squared. And then I add those. What is 64 plus 36? 100. Does that equal the hypotenuse? No. That's the square of the hypotenuse, right? So how do I get just the hypotenuse? I take the square root of everything. Because if I take the square root of a square, that cancels out and leaves me my variable. And what's the square root of 100? 10. So my hypotenuse is 10. So any questions about that? Okay. So that's how you find a missing hypotenuse. Well, sometimes you need to find a missing leg. So in this next example, one leg is X, one leg is 3, and the hypotenuse length is 5. So we got to find X, which is a missing leg. So we're going to use A squared plus B squared equals C squared. Does it matter which leg is A and which leg is B? No. So I'm just going to say X squared plus 3 squared equals 5 squared. Be really careful and make sure your hypotenuse always goes in for C. Okay, A and B don't matter. C has to be the hypotenuse. So X squared plus what's 3 squared? 9 equals what's 5 squared? 25. And then we get X squared by itself. So I subtract 9 and I get X squared equals what? 16. And how do I solve for just X? Square root of both sides, and X equals 4. That's a special right triangle, 3, 4, 5. We'll talk about those in a little bit. All right. Y'all try this one for me. Are you looking for a leg or a hypotenuse? All right, y'all try it real quick on your paper. And why don't y'all simplify that radical, since we practiced that yesterday. Do not give me the decimal. Please reduce your radical. Simplify it. It will reduce. There is a square that goes into that number. All right, so we're looking for the hypotenuse. So how do we set up this problem, y'all? So what did y'all put for A and B? So 4 squared plus 6 squared equals, you could leave it C or you could call it X since they called it X. What is 4 squared? 16, not 16 squared. 4 squared is 16. Plus what 6 squared? Equals X squared. What is 16 plus 36? Equals X squared. So to get it to be just X, we have to take the square root. And there's not a perfect square root of 52. So what is the largest square that goes into 52? 4. So that's radical 4 times 13. So what's the simplified result of that? Equals the length of the hypotenuse. Raise your hand if you got 2, radical 13. Now if it says approximate the length of the hypotenuse, that's approximate is a clue word for what? You can round the decimal. Okay? So if it says approximate, yes, you can give a decimal. If not, give the exact answer. So leaving radicals in your answer, simplifying radicals is exact answer. All right? If it says approximate, you can give a decimal. All right. Y'all like my picture? You don't have to draw it. You could just set it up with me, okay? It says a 16-foot ladder rests against the side of the house. So here's my ladder. Here's my house. Isn't it cute? All right. And the base of the ladder is 4 foot away from the house, 4 feet away from the house. So here's my ladder leaned against the house, and it's the end of the ladder goes to 4 feet away from the house. And this is my little right angle in case you was wondering. I drew it kind of big. Hopefully my house wall is straight and makes a 90-degree angle with the ground, hopefully. Approximately how high above the ground is the top of the ladder? So they're looking for how high up on the house the ladder reaches to from the ground. Does that make sense? So we have a little right triangle that the ladder makes with the ground up against the house. All right? So am I looking for the hypotenuse of that right triangle or a leg?
Leg.
The leg. So how do we set it up to find that leg? A squared plus B equals C squared. All right, so what are my two legs? 4 and X. It doesn't matter which one you put for A or which one you put for B. Do we know the hypotenuse? The hypotenuse is the ladder, isn't it? So is everybody okay with that? So then I fill it all in. What's 4 squared? Plus X squared equals what? 16 squared? It's on the board. And then I subtract 16 on both sides. So X squared equals 240. Take the square root. It says approximately. Clue word. What does that mean I can do? I can round my decimal, right? So take the square root of 240. And let's round that baby.
15.
That's close enough to 15 and a half, isn't it? So approximately 15 and a half what? Feet. Good job. So remember, word problems need some units in there. So is everybody okay with how we got 15 and a half feet? Let's check and make sure that answer makes sense. If I'm looking for a leg, is it ever going to be longer than the hypotenuse? No, a leg should always be smaller than the hypotenuse. So do we get a number that's smaller than our hypotenuse? Barely, but it is. Okay? Good job. I'm going to skip that. I think y'all are good on this. Don't y'all agree? All right, the next thing we're going to do in section 7.1 is find the area of an isosceles triangle. Now, what's an isosceles triangle?
The legs.
Two sides are the same and two base angles are the same measure. Good job. So we want to find the area of the isosceles triangle with the lengths of 10, 13, and 13. So my two 13s are my same length legs. And we want to find the area of a triangle. Can anybody tell me what the formula for the area of a triangle is? 1/2 times the base times the height. Very good. Do we have the length of the base?
Yes.
Do we know the height of the triangle? No, because remember the height of the triangle is like an altitude. It's perpendicular to the base, isn't it? Right? The height of a triangle is perpendicular to the base. My 90-degree angles are looking kind of crazy today. All right. So we need to find the height of this triangle. How do you think we're going to find the height of that triangle? Right, because it's perpendicular, that means I have a right angle. And if I have a right triangle there, then I can use Pythagorean theorem. Now, first of all, I'm looking for a leg right here. The height is a leg, right? What's this little short leg going to be, though? It's 5, right? So for that to be the height, it's got to be on the perpendicular bisector of that side. So that means this side is 5 and this side is 5. Does that make sense? Because the whole base is 10. If I drop an altitude down a perpendicular line, then we know it's got to cut it in half. All right. So how am I going to find the height now?
A squared plus B squared equals C squared.
Pause for just a second. Thank you. Unreasonable. All right. So I can do Pythagorean theorem to find the height. So h is a leg, right? So I can say h squared plus, what's the other leg? 5 squared equals 13 squared. So h squared plus what's 5 squared equals what's 13 squared? How come only one person's participating? Somebody besides Eli, tell me what I do now to get h by itself. Thank you. So h squared equals, and then I take the square roots. So the height is what? 12. Now I'm not finished with this problem. I just found the height. I need to find the whole area of that triangle. So do I have everything I need to find the area now? Okay. So I'm going to say area equals 1/2 times what's my base length? Is it 5 or 10?
10.
It's 10 times what's the height of the triangle? 12. So half of 10 is 5, and 5 times 12 is what? 60 what?
Feet squared. Meters squared.
Square meters. Area is always in square units. So make sure you get your units correct. So any questions on how we did that? We had to drop a perpendicular, find the height of the triangle, and then plug it in to find the area. So this should be 60 square meters for the area. Any questions? Let's do it again on this one. Now this is kind of like an upside down isosceles triangle from how we usually see them. Okay? Most of the time the base is on the bottom of the triangle, but is the base on the bottom of this isosceles triangle? No, the base is on the top. And I know that because these are my two congruent lengths. So your height will actually be from the base down to the vertex angle, we call those. So we got to find the height before we can find the area, because we have to use area equals 1/2 times base times height. That's just be h. So what's h is one of my legs. What's my other leg length? 15. Does everybody understand why that length is 15 and this length is 15? All right, somebody besides Eli, tell me how I'm going to set up my Pythagorean theorem. Equals. Very good. So 8 squared plus, what's 15 squared? 225. Equals what's 18 squared? 324. They're on the board. And then what do I do to solve for h? So 8 squared equals 99. Well, since we're doing feet, it makes sense to approximate this, doesn't it? Because we don't say like 2 radical 6 feet. That makes no sense to a carpenter, right? Yeah. So y'all can approximate this for me. Okay. Before we punch in our calculator, let's use our brains for a second. What perfect square is 99 really close to? 100. And what's the square root of 100?
10.
So the square root of 99 should be just under 10, shouldn't it?
Yeah, 9.9.
Is that what you get when we put it in the calculator? Approximately 9.9 what? No. Are we finding the area?
No, it's just feet.
Oh, so it's just the height, so it's just feet. Okay, we haven't found area yet. We're just looking for the height so we can find the area. All right, so we can find area now. So area equals what? 1/2. What is the base? All of 30. And what's the height? 9.9. So area equals I'm going to say it's approximately because I rounded that 9.9. Half of 30 is 15. What's 15 times 9.9? Approximately one. I'm trusting you. 0.5. What's my units?
Square feet.
Square feet. Very good. So any questions about that? All right. I do want you to get out your book and try number 6 on page 435. I don't have to get mad and slam them or anything. All right, check your answer with somebody. That's green either. All right, does mine look like it's drawn correctly for number 6? Okay. So, if you want to find the area of that triangle, you're going to use area equals 1/2 BH. Do you have all the information given to you? No, which one's missing? The height. And this really looks weird because the height is turned sideways. Y'all see that? Because the base is the part that makes the 90-degree angle. So 20 is the base. So how do we find the height? Where did 10 come from? Right, half of 20. So this leg is 10 and this leg is 10. Do y'all agree? All right. So you're going to say h squared plus 10 squared equals, what's 10 squared? What's 26 squared? And then you subtract 100. Did y'all approximate? Oh, it is. What is it? 576, right? And you take the square root, and the height is, does that make sense? Is it smaller than the hypotenuse? Yes. So 24 meters is your height. So you have area equals 1/2 times what's your base? 20. And what's your height? So it's 10 times 24, which is what? 240 square meters. Raise your hand if you got 240 square meters for your final answer. Any questions? All right. Let's talk about Pythagorean triples. A Pythagorean triple is a set of numbers, positive numbers, we call them positive integers, that satisfy a squared plus b squared equals c squared. So there's different clusters of 3 numbers that easily make right triangles a squared plus b squared plus c squared work, or equals c squared work. And they're named by the numbers. So 3, 4, 5 triangles. You usually see those together. If you have a 4 and a 3 for 2 legs, and 5 is going to be the hypotenuse. That's what it's going to work out to. And also, their multiples are also that triple. So if I double everything, you could also have a 6, 8, 10 triangle. If I triple everything, I could have a 9, 12, 15 triangle. That's a 9. If I quadruple everything, I could have a 12, 16, 20 triangle. And those are all simplified to a 3, 4, 5 right triangle. Okay? Another common triple is a 5, 12, 13. Another one is 8, 15, 17. Last year, in 2017, you might have heard people on August 15th saying it's Pythagorean triple day or whatever. That's because 8, 15, 17 is a common Pythagorean triple. Okay? They satisfy right triangles. So you can check these. If you add the 2 smaller ones or square the 2 smaller ones and add them, you should get 17 squared. And same thing for their multiples. Okay? So if we double them, triple them, quadruple them, on and on to infinity, they still make a right triangle. So there's just some common ones you see. They can actually help you solve problems really quickly by recognizing the triples. Okay? Obviously, the Pythagorean theorem always works, but if you can recognize that something is a triple, you can solve it really quickly. There's a good, page 435 right there, has a good box of them. Okay? So that might be something worth taking a picture of and keeping it. I should have did it on your handout, but I didn't. I apologize. So, for instance, this one, find the length of the missing side using 2 methods, Pythagorean theorem or the triple. I'm just going to look at the triples. If you look on that page 435, you're looking for 2 legs that are 10 and 24. And actually, if you divide them both by 2, you get a 5 and 12. So that's a 5, 12, 13 triangle. If you double 13, you would get 26. So the hypotenuse would be 26. So it's just a quick, if you recognize that it's a triple, then you can do it quickly. So if not, use Pythagorean theorem, it always works. But that's just a shortcut. Okay? Pythagorean triples are just a shortcut way of finding the missing side. All right, so that's all that I've got for section 7.1. We are going on into 7.2, which talks about the converse of the Pythagorean theorem. Now, this is on your handout, so you don't have to copy the converse theorem. It is on your handout. Basically, the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. Meaning, the sum of the squares of the length of the legs equals the square of the hypotenuse. Okay, so if it's a right triangle, then a squared plus b squared equals c squared works out. Okay? The converse theorem basically says if you have a triangle such that a squared plus b squared equals c squared, then it is a right triangle. Okay? So the converse theorem proves that you have a right triangle based on having a squared plus b squared equals c squared. Okay? So again, you don't have to write it out word for word on the screen because it is on your handout. If the square of the length of the longest side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So if Pythagorean theorem works, then you have a right triangle. So what we're going to do is we're going to test triangles to see if they are right triangles. They're going to give us some triangles, and we have to decide if they are right triangles. Now, so that means if we take these amounts, these lengths, and plug them into a squared plus b squared equals c squared, if that comes out to be a true statement, then it is a right triangle. If a squared plus b squared does not equal the square of the longest side, then it is not a right triangle. All right? So, the only thing that matters is that you use the longest side for C. Okay? You need to make sure you use the longest side for C. So, what side do you think is the longest? 9, 15, or 3 times the square root of 34?
3 times the square root of 34.
Why do you think so?
Because it's the hypotenuse.
You don't know that. You don't know you have a right triangle.
Well, take the square root of 34 and
Multiply it times 3. So let's do that. Take the square root of 34 and times it by 3. And is that the longest side? Yeah, because that's approximately 17 and a half, isn't it? Did y'all get that? Close to 17 and a half when you approximated this?
Yes.
Okay, so that should be the longest one. So that should be plugged in for C. So I'm going to say 9 squared plus 15 squared. And I want to know if that equals 3 radical 34 squared. And I'm going to put parentheses around that because I have to square the whole thing. So next I'm going to square everything. What's 9 squared?
81.
Plus what's 15 squared? 225. And this 3 radical 34 squared, you got to square everything. So what's 3 squared? And radical 34 squared, you cancel the radical and you just get 9 times 34, right? See that? Square the 3, and then square the radical just leaves you the inside. And 9 times 34 is 306. If I add 81 and 225, do I get 306? So, the Pythagorean theorem worked, didn't it? So, yes, this is a right triangle. So, if I check out both sides of my sum of my squares of my legs, that equals the square of the longest side, then it is a right triangle. Okay, if it works out to be true, then you say yes. All right, this one's a little bit simpler because it's easier to pick out the longest side. So which side is the longest here?
26.
26. All right, so that's going to be my C. So I'm going to test out 22 squared plus 14 squared, and I'm going to see if that equals 26 squared. I'm going to put a question mark here because I don't know if it's equal yet. So we're going to square everything. What's 22 squared? 484. Plus what's 14 squared? 196. And what's 26 squared? We did that one early today. 676. If I add 484 to 196, do I get exactly 676? No, I get 680. Does that equal 676? No, it does not. So I'm going to go mark out them equal signs all the way through because it is not equal. So this one does not make a right triangle. No, it's not a right triangle. It's just a regular triangle, not a right triangle. So any questions about that? Are y'all okay with how we test a triangle to see if it's a right triangle or not? Okay. This one time they didn't draw me the picture. They just gave me the links and says, is this the right triangle? First of all, I got to know which side is the longest. What's the longest one? Is 8 longer than 4 radical 3? Yeah, you can type 4 times the square root of 3 in your calculator, and you get like 5 something, I think, right? So you would test out 4 squared plus parentheses 4 radical 3 squared equals 8 squared. And then we square everything. Yeah, I don't know. So 16 squared plus we got to square everything in the parentheses. So what's 4 squared? Times radical 3 squared is just 3, correct? Equals 8 squared. I'm seeing if it equals 64. What is, oh, that's supposed to be 16, not 16 squared. I apologize. That's a common mistake. Don't do that. Do as I say, do none as I do. Right? What's 16 times 3? 48. If I add those, do I get 64?
Yes.
Do I? I do. So do these sides make a right triangle? Yes, they do. So any questions on that? So they might give you the picture, they might not. All right. Now we get to the fun part of the lesson. I've got an activity planned for us in just a second. So this is on your handout, and you might want to write this underneath it for a cute. What I have highlighted in green, write that underneath it on your handout. It says, if the square of the length of the longest side is less than the sum of the squares of the lengths of the other 2 sides, then you have an acute triangle. So if it equals it, it's a right triangle, correct? Correct? If this equals it, it's a right triangle, okay? If the hypotenuse, the longest side squared, is less than the sum of the squares of the other 2 sides, then it's an acute triangle. Okay? Less than is an important word. You might want to highlight that. Circle it. So we're going to do our setup backwards, c squared, and then compare it to a squared plus b squared. Okay? So if this turns out to be less than, then it's an acute triangle. And the opposite, if it's greater than, then it's an obtuse triangle. So let me write that one. If c squared is greater than a squared plus b squared, then it's obtuse. Now c has to be the longest side. You might want to write that down. C is the longest side. And you can just write this on your handout. I'm writing it for both of them. C is the longest side. So if it equals a squared plus b squared, then it's a right triangle. If c squared is less than a squared plus b squared, it's an acute triangle. If c squared is greater than a squared plus b squared, it's an obtuse triangle. All right. They might not even form a triangle at all. We learned previously, I believe it was chapter 5, I believe, that some numbers don't even make triangles, right? Some lengths do not even make triangles. Do y'all remember what that criteria was for it to even be a triangle at all? Yes, if you add the two shorter sides, it has to be greater than the longer side, right? Otherwise, your legs won't meet up and form a triangle. All right? So, can segments with lengths of 4, 5, and 6 make a triangle? Which two are the shorter ones? If I add that together, is that more than 6? Yes. So, yes, it does make a triangle. It makes one. If it does, will the triangle be acute, right, or obtuse? So we're going to fill it in based on c squared comparing it to a squared plus b squared, okay? Which one has to be c? 6. The longest one has to be c. So I'm going to say 6 squared. And I'm going to put a minus there because I don't know what kind of comparison symbol I'm going to use. 4 squared plus 5 squared. Okay? So if this turns out to be equal to, it's right, less than acute, greater than obtuse. Okay, so what is 6 squared? 36. And what's 4 squared? What's 5 squared? 25. So 36 compared to what's 16 plus 25? 41. Is 36 less than or greater than 41? Less than. So these will all be less than. So what kind of triangle do we have? Acute. Is everybody okay putting the C on the left-hand side? I know that takes some getting used to after we've done it. A squared plus b squared equals c squared for so long. So if the longest side squared is less than the square of the other two sides, then it's acute. If it's greater than obtuse, if it's equal to, it's right. But first we have to test and make sure it even makes a triangle. So any questions about that one? All right. Can the segments with lengths 11.2 inches, 6.5 inches, and 7.1 inches form a triangle? And then if so, will the triangle be right, obtuse, or acute? So can it even make a triangle?
Yeah.
What's my two shortest sides?
6.5.
All right. If I add these, is it greater than 11.2? Yeah, because I already know 6 and 7 makes 13, and that's greater than 11. Correct? All right. So, yes, it makes a triangle. Answer that question. Now, I got to know if it's going to be right, obtuse, or acute. So, which one's the longest one again? So, I'm going to do 11.2 squared and compare it with 6.5 squared plus 7.1 squared. So, any questions about my setup? Put your longest side on the left by itself. Then our calculators are going to help us. What's 11.2 squared? Yeah, there's only 2 decimal places. Go ahead and don't round that. Just give me all of it. 6.5 squared. Lots of calculators not getting used right now.
42.25.
And what is 7.1 squared? Yeah, I'm getting 50.41. And then I add those two together. 125, 44 over here. So add the other two. And what do we get? 92.66. So what's my comparison symbol? 125.44 is what? Greater than 92.66. So what kind of triangle is this? Obtuse. It has an obtuse angle in it. So any questions about how we get those? All right. Y'all try this one real quick, and then we're going to do an activity. If I can find my activity. There it is.
3, 4, and 6.
3, 4, and 6 are my side lengths. Tell me, is it a triangle? And if it's acute, right, or obtuse? Check it with somebody. Okay, do they even make a triangle? Yes, because 3 plus 4 are my smallest sides and 7 is greater than 6, right? So, let me find my pen. That was a good job. This is losing your pen. I just had it it's in my hand. Look at that. So, what is 6 squared?
36.
And 3 squared?
9.
4 squared?
16.
16. What is 9 plus 16?
25.
So, what's 36 compared to 25? Let's say greater than or equal to. Greater than. So, what kind of triangle is here? Obtuse. Raise your hand if you said it was obtuse. Any questions? All right. So, we're going to end with our activity, and I'm going to shut off my recording. So, goodbye.